And if I'm going for 2-port bandwidth enhancement, the shunt peaking is only for 1 port because I'm connecting only the amplifier and the load. So although the near doubling of bandwidth is impressive, it is still you have to go for a 2-port network. You have to between the amplifier and the load. 2-port means the amplifier is going to have input and output. So how I'm going to enhance the bandwidth of a 2-port network? So I have to do it separately. For the input side, I have to do shunt peaking, and also at the output side, I have to do a separate type of peaking. So if I'm going to use additional, if I'm going to separate the load capacitance from output capacitance, I have to use a series inductor for peaking my response. So that is called a shunt and series peaking. So depending on how we are going to nullify the effect of capacitance, I'm going to go for shunt peaking or series peaking. So see here shunt and series peaking. So here you have both. See here the inductor is in series, and it is in series with R, and here you see the inductor is actually in shunt with the capacitive load. Okay, so you can see it is both series and shunt peaking, series shunt and double series peaking. So double series means I'm going to have two inductors which is going to be connected at the midpoint of the load. The RL is there. I have one inductor here, and finally I want to have capacitive load. So this is going to provide double series peaking because I have two inductors in series. So it is going to provide double series peaking for a 2-port network. Okay, and it may be shown that the bandwidth is increasing by root 2 times. So on root 2 is 1.414. So series peaking and shunt peaking, so which is best and which is not best, there is no topic to debate that. So as long as my peaking is under control and the bandwidth enhancement is good, I don't mind going for series peaking or shunt peaking. Okay. So for that, what value of maximum value of m I can get? So where m is equal to corresponds to maximum value and maximally flat amplitude. So different values of m they have found. When m was equal to 2, they say that the device had maximum bandwidth and the amplitude maximally flat. The peaking was not there. When m is equal to 3, they put the bandwidth was increasing by 1.36. So now that's what for double shunt peaking they say add inductance, one more inductance in series, which is going to help you in giving you the required bandwidth. So you have normal peaking, shunt peaking, and series peaking, and here you have shunt and double series peaking. So I have two inductors in series, which is going to enhance the bandwidth of my circuit. That is what is given here. To save the die area, the combination of three inductors can be done together. So you know that I'm going to have, for peaking, I need to have inductors. And we have seen today how inductors are very difficult to fabricate. So I can conveniently fabricate the three inductors together on a single chip. So I can use spiral inductors placed on top of each other to produce the necessary inductive effect. And also you can between the inductors you can generate a resonant effect by creating a bridging capacitance. Okay, and one particular circuit which uses is going to be a shunt series amplifier, or it is going to employ negative feedback. So it results from the term that it has both shunt and series peaking. Okay, so one example of this 2-port bandwidth enhancement is shunt series negative